Everyone, welcome. It's really nice to see many of you here today. This workshop is sponsored by Chinese historians in the United States. If you are a historian or working in any related field, please feel free to join us. I think like people still keep coming. Um, I think it's an obvious, reason why we have such relatively, bigger group today. We know, like in the past few years, AI really reshape and is reshaping quite forcibly our research, our teaching, and our daily life. So speaking for myself, I never feel comfortable. I really dislike the feeling of being passively pushed by new technology. But I don't have a choice, right? We are living at this historic moment. So because of that, I imagine many of you must share the same mix of the curiosity, urgency, and maybe anxiety that I do. So we want to know what AI actually means for our work. So today we are very lucky to have three wonderful young scholars who are exploring AI in ways that are both creative and also closely connected to our humanities methods research. So they will show us what they do with AI tools in their own research, and how these tools can probably open up new possibilities for our future research. So as usual, each of our speakers will lecture for half an hour and leave half an hour for Q&A. Okay, so our first speaker today is Dr. An Bo. His last name is An. So An Bo serves as a research assistant professor of history at Lingnan University. He holds a combined PhD in East Asian languages and literature and film and media studies from Yale University. His research interests include history of AI, computing, software, and modern Chinese history, digital humanities, digital history, research software, engineering, global history of science technology. So based on research into the history and the theory of information technology in modern China, his dissertation examines the rise of computing in the People's Republic of China between the 1940s and 1980s. He is currently investigating post-1980s applied computing and the longer global history of science behind it. In addition, he is also the founder of an online community forum, Digital and AI Humanities, which serves as a central hub for researchers, practitioners, and learners of digital technologies in humanity and social sciences. I will later paste the website on our chat box. Anyway, without further ado, I will turn it over to An Bo.
Thank you, Linyi. Can you guys hear me all right? Great. Thank you so much. Good morning, good afternoon, and good evening, wherever you are. My thanks to Professor Yi for the invitation and my final panelists for this opportunity to share some of my experience and tips with regard to AI-assisted research workflows. The topic is documentation-oriented AI research workflows. If the first part of the title sounds unfamiliar to you, I hope at the end of this talk, you will get to know the notion and can apply it in your own practice. So the aim of this talk is simply to share with you the current state of using AI in everyday humanities research. And also, I would like to highlight a recent paradigm shift happening to the application of AI. So in what follows, I will first give you an overview of the current state of AI application in professional settings. Then I will spend the rest of the talk, about 30 minutes or so, to showcase some tasks that are common in humanities and history research. And I was hoping these examples can illustrate the key concepts along the way. I also prepared for you a template on GitHub that you can clone and use for your own work. I think all of the examples I will show you in this talk are well covered in this workspace. So first, about where we are really in AI right now. So I guess you've heard news about AI models popping up every 2 weeks, claiming themselves to be launching a new revolution in AI. But I was just hoping to give you a brief sense, have a sense about what really where AI is currently. Um, I think people know about the revolution, so-called, launched by the ChatGPT version 4. But after that, really, it was about 1.5 years ago, around fall 2024, there was, I would say, another shift in the way people work with AI. It was not just the models just got so much better. Back then, it was ChatGPT o1. It was one of the first thinking model, but also the Cloud 3.5 model. So the way it changed people's workflow is that before AI was not so deeply integrated into individual workflows. But after around that time, I would say end of 2024, it kind of crossed the intelligence threshold for real and more autonomous production use. And then in the last few months, the latest models, ChatGPT, Cloud 4, and ChatGPT 5, the latest models are 4.5 and ChatGPT 5.1, have also become even better. Currently, they can not only follow and understand complex tasks, but can also take a lead and automate the process for you. And this process of working with AI and having AI taking the lead has been becoming mainstream in the software industry. In other words, the shift, you can understand it and as AI moving out of the chat box. So this is what it was like before. I paste my command into the chat box and I wait for the response, then copy it or manually edit for my purposes according to the responses. Now it kind of changed more into something like this. It is using your terminal. This is terminal software, and you interact with AI through text in your own computer and letting it touching your files on your own computer. To give you one example, that's a grammar check example. So before you open your document to proofread, you copy a paragraph, you paste it into AI, and you wait for AI to generate a response. And the step 4 is really the only step that AI is truly involved. And then you do the rest of the work manually. Uh, Currently, the popular way of interacting with AI is to point AI to your file with a prompt or to your prompt stored in a file. And then you let AI do the rest of the work. It will automatically retrieve the document according to your instructions and follow your rules set in the prompt. And then it will apply edits directly on your files. And your responsibility is becoming more of that of a reviewer. And you review and approve or undo or ask for further revisions. So now AI does most of the work and you supervise. This is so-called revolution. And this the use of terminal text-based CLI tools is one of the a broader trend that AI is not only manipulating your files, but also can do things such as control your computer or using your browsers to browse the web. For instance, we all know the headache of having to filling in some forms on a web page, and AI can do this for you. Of course, there's privacy concerns, but now it can. And it can also see your screen in real time and chat with you in real time, watch what's going on your screen and respond in real time. So in other words, this is both a move from a chatbot to a real assistant, but also in the mode of AI behavior that's changed from a completion agent to an agent that works. In Chinese, people call it 智能体. In English, just agent. And an agent isn't some mysterious thing. It's really not that complicated. It's just a model that decides what to do following the rules you set beforehand, and then uses so-called tools to achieve it. I will explain what tools means later on, and then gives you not really the response, it's actually to give you the result. So that's what 智能体 and agent means. So I would say AI has crossed the threshold. AI has became kind of the writing subject. They are editing the files and running the commands. And before, AI was smart, but they needed a lot of effort to harness because they hallucinate, they fail to comply with rules, they forget the context. But as of now, AI has crossed the threshold for more autonomous use. And so back then, it wasn't that we didn't think of letting AI operate computers. It was just that they weren't smart enough to do so. And both the channel, the way we interact with AI, and the message have changed. So techniques that seemed essential a while back, when, for example, ChatGPT 3.5 or 4 were launched, are now much less important or relevant. For instance, there was a lot of talking about the importance of prompt engineering, as well as the use of RAG in any kind of real use of AI in a pipeline. But with recent changes, it's all of the three factors: the models getting better, the tools moving into command line, as well as the fact that the models have again more capacity, such as context. So they no longer use it since no longer rely on things like RAGs that much. This is getting a bit technical, but just my point is just that the recent shift also kind of already is retiring some of the early techniques, and they are much easier to use. So they are now currently smart enough to do things just as well, if not better, without any kind of human assistance or software assistance such as RAG. And how good is AI really now? Currently, when you look at the model, this is what they call model card for an AI model. This is for Gemini 3. It was recently released. And you see a bunch of names for benchmark they run against this model, and shows how good they really are, and compared to some other models, as you can see. But one thing is kind of missing is more tests for humanities tests. I would say humanities last exam is kind of like that, but it's more like a reasoning test. And the MMLU test, this is one, and there's another one, I think, yes, here. It has some humanities subjects, such as law, history, but it's more like textbook understanding, textbook knowledge kind of test. It's not really that tailored to our needs as researchers. So currently, kind of humanities benchmarking is still lacking. And actually, one of my recent work is precisely to develop this kind of benchmark for research software in humanities. But as of now, I can only give you my kind of personal assessment. Each one has their own assessment. But mine would be that they are as good as they are. They're not so good at ideation, and they shouldn't be, because that often requires grasp of literature and also significance, right? Why we do this at all. And I would say it's not that good at writing academic prose. And I trust that you share the view if you tried to ask them to do that. But they are good at thinking bodies. They are also very good at reading and processing. So I would say that they are no longer the bottleneck anymore. And the bottleneck for accomplishing any kind of task in humanities is really us, apart from the ideation and rating. So of course, the creative part is mostly how well we can break down a complex task into manageable units for them that are small and focused enough. And usually you don't even have to go that far. They can easily follow a rather complex prompt without much assistance from you. So in terms of model recommendations, this is really not a recommendation. It's a saying that all of these state-of-art models are about the same. They are good at some things, while others are not as good, but they are pretty much the same, I would say. So you can just pick any that one that you wanted. A more important thing to consider if you want to apply this workflow is to pick a tooling. In terms of tools, there are usually two kinds that you can use for this new workflow. One is called IDE. You can just think of it as editor. It's the office word for programmers, but more and more for non-technical users. And for CLI, that's a command line interface tools. You can use these. Personally, I would recommend you just pick Cursor and Cloud Code. Okay. And I also would want to mention that tooling matters now as much as models. For instance, Gemini 3 is really good, but with the tooling it's not as good as it should be compared to something like Cloud Code, which is really achievement in software engineering. Okay, now examples. So I was hoping to use 5 examples to demonstrate the so-called documentation-oriented workflow. Some of these are pretty common. Grammar check, track changes you made to your content, how to extract entities out of text. For historians, it's historical text, primary sources, and how to extract PDF annotations, which are usually our own thoughts or reflections or reading notes, and then build a minimal knowledge base without little external software. Okay, let me show you the first task. That's grammar check. So I have on the screen a passage. It's generated by AI with some intentional typos and grammatical mistakes as a base text. I launched the Cloud Code tool. What I'm doing here is to providing the agent with the two files. I provided with a path to the file I just showed you, the one with grammatical issues. And then I also provided with another prompt file called grammar check. And you see it's reading these two files, thinking, and it's giving me back my results. So far, this is no different from chat interface, right? It just gives you the response. But something else it can do is that they also wrote a file with the same base name, but added a checked, this is a postfix to this file name. And it has written this corrected content there. And then you can go back to your editor and open the view file. This is corrected version. But most often, we wouldn't want to simply just let the agents apply the changes, right? Because sometimes we need to really audit and review the changes. But if I confirm that I do want to apply them, then I can tell it to simply apply. And agents is smart enough to know that you want them to apply the corrections directly to the original file. And you see, this is the built-in diff. It's called it's a difference viewer view of this paragraph before and after the changes. But there's a better way to do that is to use this is called version control. In this is cursor. Cursor is basic VS Code. It's a modified VS Code. And then you can go to this is original file, right, with samples. Now you see the before and after versions down to the character level differences. Okay, it's very precise. And then you can decide whether to keep the changes or revert or drop the changes. Okay, now I'm showing you a bit of, actually, I think I can show, yeah, this is basically where I store the prompt. It has this so-called header. It's about the basic description about what this prompt is asking for, and then followed with by some more detailed instructions. I think I would just close this because I think I've already prepared. Yeah, also prepared this version for you. So let's just take a quick look. This is what document. This is what I call documentation. Okay, this is documented prompt. It has a name, description, allow tools means what kind of authorizations it has to perform to operate on your computers. And here are my instructions. I simply tell it that I will provide one or multiple files for it to check. And it has two modes. One mode is to review, another mode is to apply. And by default, it should act without assuming that I want to apply the changes. And then I give it a kind of a step-by-step guide about what I wanted to do. But usually these models are smart enough to know things like read specific files. And then this part is more relevant because I am being more specific in asking for proofread for reading for grammar errors, spelling mistakes, or word phrasing, clarity issues. And then I give a kind of example about the kind of output format. I wanted to output in a markdown table format. And so what you see is a nicely formatted table with the lines, original, suggested fix, and explanations. All right, this is basically it. And the language, it's not actually, it's the markup, they call it. Markdown is a marked-up language. It's this format you see, these symbols, this, and this. These are all so-called markdown markup syntax. And the hash pound simply means heading level 1, double hash pound means heading level 2. And this means emphasis, so it'll be rendered as bold, and this is italics. You can also add bullet lists simply by adding a hyphen with space between the symbol and your content. And you can also number them. All right, it's super easy. I highly recommend that you run them. It's super easy. I would say it takes between 5 to 30 minutes really to learn the basics, and it's super useful. Let me show you another example following this. So this time, I hope to show you how it would work without the prompt I just showed you. Okay, so this is complete new instance. It knows nothing about my workflows or its expected workflows. I just provided with a simple one-word instruction that's proofread, followed by the document, thinking. Oh, sorry. Right. So this is the kind of response it gives. Sorry, I'll say pretty good. It's to the point, very concise, but it's not following my instructions, right? So now I will do something different. Now I wanted to follow my instructions, but use a different file to provide the context. And this file is called agents, right? Let's see how it worked now first. Again, a simple instruction proofread with the path. Okay, you see, it's doing something different. It says that I will check for available skills to handle this proofreading task. And it's searching for prompts that are relevant to this task of proofreading. And it's smart enough to find because it can list and see all the file names, right? It sees the grammar check file and it guessed correctly that it's the prompt that we might want it to use. The same result using the same format, okay? The same default review mode is acted out too. Right. Okay, so what's happening here is that I provided it with a so-called, I think you can call it a guide document, a portal document. It's basically a short document pointing to agents to references, to documents that agents might find helpful or where the agents might find the rules that they are expected to follow. All right. And the name is usually the agents dot markdown. This is becoming a standard, even though some of the CLI tools, such as Cloud Code, has its own standards. Under Cloud, it's called Cloud dot markdown. But the idea is the same. So it's a central file that sets general rules, points to skill when needed, and AI fetch them, fetch whatever they need. So in my case, in the workspace I shared with you, and later on I will provide the link again. This file is placed as the workspace root with the skills added under a agent subfolder, like this. Okay. It's basically a crucial technique for us, the user, to scale our documentation. Because let's say I'm working on a paper project in a single workspace, and there are many research stages involved. So there are many tasks I hope the agents can help me. So there will be multiple prompts at different resolutions. Some are more like general overview, general rules. Some are super nitty-gritty specific rules I expect agents to follow. And this is how we want to organize them so that we can let it grow almost infinitely without overwhelming the agents with instructions. And currently, there are other terms you might see in guides and tutorials, such as skills, commands, and agents, custom commands. But they are basically all the same ideas. That's for document controlled behavior. And that's something that you can reuse across projects. And also, the idea is about AI reading on demand. So, if I were to give a simple rule about when do you want to write a separate prompt, that would be if it's something that's over 500 words, then that's when you want to write it as a separate markdown file. And then you tell AI if you need to do X, you read that document, something like this, right? This is just one line in your agent doc. You say, when processing historical sources, follow guidelines in this file, and agents will go and read this file by themselves. Okay, let's look at another follow-up task. The same paragraph. These are the changes we made last time. Now I'm asking the agent to evaluate the current status of this workspace. Basically to ask it where I was, what was the recent changes, And then it will run commands like this. Bash means it's running in your terminal, in your own computer. Let me go back a little bit. So it's running these commands for you. These are so these are Git commands, and it will run multiple commands, and then it will summarize the key changes that I asked for. And the last one is most relevant. It says that there is currently one modified file not yet committed. Okay, that's one file where we just applied changes in a grammar check. Then if I want to commit this change, I can simply say, please help me commit these changes. And then it will run first git diff, and then it added to our git and committed with a git commit message like this. Okay. I intentionally skipped the details and explanations about what it's doing here because it's doing something that's um, simple in ideas but complex in operations because it involves a lot of commands. But basically, what it does is to save the changes in a way that you can track them back. By tracking them back, I mean, this is the new commit it created, and it has a list of past changes. This is to your workspace, but that you can also view the recent changes to a specific file. Let's say this file, I made changes to it twice. Then it will list two separate commits, each with its own commit messages and the details about what has changed in that specific commit. All right. But what I was hoping to show you here are two things. First is idea of versioning. Versioning is very important, and even more so in a AI-assisted workflow, because AI can make a lot of mistakes without noticing. We always want to keep track all the changes it made to our content. Here, the first thing I hope to mention is that the agent just used, which is also a industry standard, is so-called Git. And Git is not equal to the more famous GitHub. GitHub is a platform that kind of use Git to its fullest, I would say. But it's different from Git. You can consider Git as something to help you to control your versions, to archive your versions, and you don't really need a GitHub to use it. But it's recommended that you do so. And Git itself is super, super important, but also very complicated. And this is also where AI comes in, that it can help you with it. So what I just told it is basically, I want to save this, and it knows the correct Git commands to use to help you save your work. Okay. And of course, it can make mistakes, and sometimes it's me, the user, who are making mistakes. For example, I say, "Oh, please undo the changes." But what I actually mean is that please change this particular word back, but keep other changes. But if I'm not being specific enough, the agent might think that I want to undo the last changes, then I will lose more than I wanted to. Um, and what this means for historians is that with version control, you can make sure that nothing goes into your content without your approval. And every change is tracked down to the letters, including who made it, which is important for collaborative projects. And even if AI makes a mistake, you can always undo it. And for us, it's also a natural replacement for existing versioning practices, such as using the file names to name your Word drafts, for example. Okay, let's see a more historian-specific task. All right. So this is a passage taken from Journey to the West. This is plain text. This is just one paragraph stored in this plain text file. Launching the CLI tools again. And this time I'm pointing it to an entity extraction skill I prepared for it. And of course, as I showed you, you can also use agent.markdown. And then I point to the file I wanted to process. Of course, I can also point to a folder. Great. This will actually take some time. It's extracting entities from this classic passage. It already recognized it to be a passage from A Journey to the West, and is following the rules as set in the entity extraction skills prompt. Let's see if we can skip a little bit. Okay, it's taking much longer because this is very heavy. Okay, yeah. Now, that's finished the extraction process and showed us has written it into a file and also gives us some basic statistics about the things, the entities it extracted. It extracted characters, fiction characters, such as 齐天大圣, 王母娘娘, and other entities, types of entities such as location, object, and events. Okay. So what it produces is not a textual response. It's in fact produced a JSON file. This is what's called structured response because it's responding with something that programs can directly use, not natural languages. This is a JSON, and these attributes can also be validated with a schema. For here, for instance, it knows and correctly recognize and extracted Wang Niangniang as a character, and it kind of guessed at its role as playing a supporting role, and included the original context from the raw text. It also gives kind of attributes. And it also gives kind of relationship to other characters and inferred false source reference. So just one thing I want to mention is that you should be careful about this kind of, there are two kinds of usually information it can extract. First is text-based. It has a grounding in the source text. But there are other things such as its role, like supporting characters and attributes. These are derived knowledge, and these attributes are usually likely to be to involve hallucinations. Okay, so for entity extraction, I want to highlight a few points. First is that in your prompt, you might want to remind it to only extract information explicitly mentioned in the source text. No external knowledge, meaning knowledge embedded in the model itself, no inferences, unless it makes explicit. And actually, you should ask it to include a confidence score for the kind of inference, because recent studies show that models can provide kind of reliable confidence scores about their outputs. And you might want to ask it to not to hallucinate translations. But of course, this usually don't work. If they want to hallucinate, they will hallucinate. And you can specify the output format. And one of the most useful technique you can apply in a task like this is to give them a few examples. This technique is called few shot prompting, but it means simply to give it 2 or 3 standard examples about the desired output. For instance, you can get a one sentence or one paragraph raw text, and then give a short output text as the example, and then AI will quickly learn the pattern. Even though AI are usually smart enough for zero example prompting, but usually you see a huge increase in performance if you just started with a few examples. But again, AI definitely will still hallucinate no matter how hard you prompt it. So for really serious work, for example, if you really want to set up a database extraction and construction project, you want to set this entity extraction as part of that pipeline, then you need other parts to make it work and multiple rounds of review, human loop, human review, agent review, schema validation using scripts to validate. Um, a lot of other things really to make it a serious, trustworthy work. Okay. In this next task, I will ask it to extract my annotations out of a PDF document I was reading. Again, I'm providing it with a prompt about the skill, and then I point to the PDF. It looks similar to what I've just demonstrated, but it's using a different route. It's calling this called MCP. It calls th tools, extract annotations, and these parts are things that the agent provided called file paths. Is the input file path, and this is output file path using Markdown. Okay. So what it does is that you see it's super fast, right? It used a few seconds to process this. And it already told me it extracted 6 annotations, right? It's much faster than the last example we saw. Why? Because it's using external tools. What the model really does is not, it's going into the PDF to extract annotations by itself, but it's using a tool I provided, I prepared for it, actually also written using AI, which will handle the heavy lifting work, which is extracting the annotations out of the PDF documents so that the agent can simply call the tool and get the result. So it will output this file, even though this is directly outputted by my MCP server. So it shows all the notes, all the annotations I made in my PDF. With this, I was just hoping to show you the notion of MCP. The MCP is short for Model Context Protocol. It's a standard way is, I would say in foreseeable future, a standard way for AI to call external tools. For example, it will let AI agent to not only read files, run commands, and search the web, which they are already able to do, but they will allow them to do things they are not able to do, or some domain specific tasks that they naturally should not be equipped to do, such as extracting annotations. So what I did is to create, by the way, this part of source code is also included in the workspace, so you can spec the source code by yourself. I simply defined an endpoint for it to use. I call it extract annotation. It's explicit. And I also explained that it will extract all the annotation from a PDF file, and I expect an argument, which is something that the agent should provide, called file path, and then it will return a dictionary. Please note that these documentation, these explanatory notes are not for me, the user. These are for the agents. That's why they are called MCP. They are providing a context of the tool for the agents to use. So when agents are asked to perform a task that they are not equipped with, they can go ahead and read these definitions and add documentations from these MCP server. What's it called? These are MCP endpoints. Okay, so they will know that they can call this tool and get the results they needed. And you might ask, why don't I just ask AI to write a Python script instead? In fact, that's a pretty valid point, because you should, in most cases, start with a Python script or a script in other languages, because that's ideal for prototyping purposes. You want to try out whether the script works at all before consolidating it into your MCP server as one of the MCP tools, because MCP tools usually have better lifecycle control, environmental isolation, meaning, for example, if you are running it in another environment, the server should have already taken care of the environment setup and the dependencies. So it's not like a script. Each time you might want to activate this virtual environment or something for Python scripts, at least. And it's also natural for agents to discover the tools, and also they are reusable across sessions. And one last example is a more complex task, which is to build a knowledge base. I will show you what it means. So from this passage, I highlighted this part. Sorry, this part is about the guests at this feast, right? These are a number of goddesses or gods. And what I wanted to do is to sorry, process and index this passage in a way that I can retrieve them later. All right. So I simply asked it to index this file into our knowledge base. This is also using a MCP service I wrote with help of AI, and these are also in the workspace. So immediately, because it has access to the MCP function information, it knows how to index the file into the knowledge base. And it's ingesting that. Ingesting, it's just a generic term meaning to parse and store the documents in certain way in a store. And here we call it our knowledge base. The indexing has finished. Now it told me that I can search with knowledge base, search for semantic queries. So what does semantic query mean? It means that I can search with natural languages, even though, for example, the original text is written in Chinese, I'm searching using English. All right, and I don't even know the accurate term for the goddess. I simply said that please find out whose guests are in this mentioned in this passage on the Feast of Peaches, 蟠桃会. Again, it called the MCP to perform a semantic search. And the server is giving back responses to the agents. Now the agents has the raw materials to further process, and it will kind of interpret these results for us in response to our question. So it's a collaboration between the MCP and agents. The MCP is returning these results with a score of relevance using top K parameter for the similarity search. And these are source materials we just indexed into our knowledge base. And this is the second entry. After receiving these results, the agents will think how they will want to use these materials in response to our queries. And now you see, it's able to give us answers based on real knowledge, meaning these are knowledge not embedded into the model themselves, which are often subject to hallucination, but they are integrating our knowledge base into the process of answering our questions. And you can actually paste the results and kind of do a simple double checking yourself. So you see that these are the answer that the agents gave us, and these are the original texts, and you see there are matches. And with this, you can build a more complex knowledge base across both your content, such as primary text, as well as your own thoughts and work, such as your drafts, your notes, your research journals, for your own use. Okay. So to wrap up, basically, I hope that the previous examples showed you that currently the paradigm has shifted to the state where writing prompts equals writing software. And when you write prompts and documentation for AI, you are already writing software. And as after a few iterations, your prompt will become more and more suited to your own needs, and which I would argue is much more helpful than the generic AI apps that you will find um, um, offered to you. Why? Because most AI software are services, because they are most of them are SaaS, so-called cloud services, are just wrappers around a AI API. They are generic often and not tailored to you. But with the documentation-oriented AI-assisted workflow, you own your prompts and you own your documentation. You own your rules and your data, and then you can create your own custom software. So this some in the development community is called spec first, specifications first development, meaning that you no longer write the code, but you write the specifications. You write down your needs. You describe what you want in natural language. You let AI figure out the implementations and build. You are building a documentation system, and AI is building the software system for you. But the key insight is that you no longer need to become a programmer to write a research tool for your own needs. You just need to write clearly what you wanted, what you needed. That's something humanists are already good at. So to start, you can try out some of the examples I showed. You can install one of these CLIs. This is the line to install the Cloud Code, but you don't have to use that. But unfortunately, most of these, except for Gemini, are all paid services. You kind of have to pay at least $20, around 20 US dollars for them for their services. And then you can clone my workspace that I prepared for you. And then you can just get started exploring and learning about how to work with it. So thank you. These are some of the useful links to my workspace, to the Cloud Code I mentioned, which I also use in my demonstration. And for the slides, they will be released soon as part of upcoming Guides to AI in Humanities, which I prepared for our website for our MA in Digital History program here at Lina University. And I also have a personal DH website where I offer some free tools for humanities scholars. Yeah, that's it. Thank you.
Thank you, Amber. Wow, thank you so much for this generous sharing. Oh my goodness, this is really, eye-opening. I don't know our audience, but to me, it's really, I feel like we are living in the different worlds. In your world, there is like one revolution or several revolutions, but I'm still like, playing mud. Anyway, I'm sure our audience will have like more smarter questions after our three speakers talk. So our next speaker today is Dr. Pan Ke Yao. And he is the assistant professor of digital history at Florida International University. He received his PhD from Department of History at the University of Chicago in 2021. He specializes in the relationship between human rights discourse and activism concerning so-called history problems in Japan and Asia more generally, and particularly those involving comfort women and other wartime colonial atrocities. So his monograph, tentatively titled Beyond the Post-War, Beyond the Nation, Human Rights and History Problem in Modern Japan and Asia, will trace how the term Jinken, the Japanese human rights, has been transformed from a nationalism, constitutionalism concept about the relationship between the national citizen and state to conglomerate discourse encompassing a degree of transnational potential. All right, Ke Yao, over to you. Thank you.
Thank you so much, Professor Renyi, for the very kind introduction, and thank you for inviting me to be part of this panel. It's very hard to say anything new after Anbo's very exhaustive, very informative, and very high-level technical knowledge presentation. But my presentation probably focused more on the lower level, more approximate, more if you say so, intuitive understanding of these tools that we're using nowadays. I believe everyone's using, and I will also talk about some tools, but mainly the presentation focus more on a visual or spatial understanding of large language models and how it could be used, as Ambo said, other than a simple chat box as a black box for critical textual engagement or humanities research. So for us today, as teachers, we probably have seen that most students and also ourselves, educators, are using AI tools, some for legitimate purposes, but others in ways that raise ethical concerns. But regardless of that, the majority are engaging with them as if they were just a chatbot or generator of text or images. There's a heavy reliance on outputs, but very little curiosity or clarity about the underlying mechanisms. So this leads to a critical gap, which is that people don't really know what these tools are good at or what they are bad at. They've heard about hallucinations that, like Ambo had talked about, yes, but they don't understand why they happen or how to anticipate them, but not to avoid them because that's always part of the package that we're getting. This lack of understanding limits meaningful engagement, I would argue, and critical usage. If you want to integrate AIs, like large language models, into teaching and research responsibly, we need to go beyond surface level interaction and start unpacking the logic behind these models. So in this presentation, I argue that both researchers and educators can benefit from developing a visual understanding of how large language models work, especially the process of embedding. Now we don't need to dive very deep into the technical architecture of how these models, how these AIs work, like transformers or the specifics of model training. Instead, we need to move beyond treating them as simple black boxes or chatbots that just generate text or images. By understanding how embeddings represent meanings, we unlock new ways to engage with these models critically and creatively. So here's how the talk will unfold. First, I'll introduce the so-called traditional methods of text analysis using word frequency as its foundation, that it kind of builds on the idea of so-called distant reading. Then I'll explain what embeddings are and how they function as the bridge between language and computation. And finally, I'll show some examples of tools that may help us visualize these intuitive understandings the tools that can be used in both research and teaching to explore meaning in new and insightful ways. Um, the historical context. So in the 2000, in the year 2000, Franco Moretti coined the term distant reading, or rather popularized the term distant reading. He contends that for literature, for the field of literature, literary scholars should move beyond close reading of canonical texts and instead use statistical methods like sampling and word frequency analysis to explore so-called the great unread, namely the broader literary system or context that the canons are situated in. This is to tackle the problem of the canon. Most literary scholars or historians, in some cases too, only have the time and energy to focus on the so-called canon, or in the Foucauldian terms, what the power structures, privileges. But there are so much text and materials that the scholars simply do not have time to read, and hence we can read them distantly, so-called, using computational methods, and in this way complement the study of the canon. 2 decades later, with the events of this guiding principle in digital humanity in both literature and history, after such methods are a bit like hackneyed in some way, Da Jiangnan and Zi Da, an expert in both literature and also well-versed in programming, offer a scathing critique of this method, arguing that the computational literary study rely too heavily on simplistic tools like word frequency or n-grams, basically what she calls just counting words without much consideration to the context of the words. And this fails to capture the complexity of the literature and will result in either obvious findings or misleading conclusions that are not replicable, with little explanatory power and significant reductionism. I also want to note that the publication date of Das article here, it's a bit before the popularization of ChatGPT, but at this time already people are indeed working on a different way of using computational models to represent it under so-called understand text that takes into the consideration of context, which leads to what Anbo was talking about, that what happened in 2022, I believe, the launch of ChatGPT. So what are the so-called traditional methods of counting words, and how did they try to mitigate the problem of context that Da pointed out? I'll just give some very brief examples, like keywords in context. So is like a way to examine the high frequency words, then put it into the context, into the text that you are analyzing. Or you can build a so-called co-occurrence network that maps how the frequent words appear together within a defined context and use them to tease out semantic associations, topic structures, and so on and so forth. Right? So some simple examples of interfaces. So this is a tool called KH Coder, developed by a team in Japan that kind of specialize more on East Asian text. Also, this is the interface of their keywords and context. As you see, it highlights all the words related to child or children. That kind of allows you to look at the context that they are in. And this is the so-called co-occurrence network, which is a graph-based representation of how words appear together with a text corpus. So each circle or node here represent a word, and the size of these nodes reflect the frequency of the word. And the more often the word appears, the larger the circle. The color depth can indicate a so-called centrality, which is basically a proxy to understand so-called how important the word is within this network, right? For example, some measures how connected it is to other words, how often it serves as a bridge between different clusters, so on and so forth. And the edges, which are the lines connecting the words that co-occurred, and their thickness represents the strength of their associations. For example, the thicker the line, the stronger the two words appear together. So all these states still rely at the foundation is simple word frequency count. And on the right, you have another way of representing that. It's hierarchical clustering that organizes words into tree-like structures, and they kind of merge the words that associated with each other one by one to kind of represent the so-called topic. And you can see that what larger topic are connected with some other larger topics. So these are the more traditional ways of doing things. But now, how does AI read or understand or represent tests? They rely on something called embeddings, which is I wouldn't go into the very technical definitions because I'll probably talk about it in a very approximate way and kind of use it in different contexts. So I probably get yelled at if I present this in a computer science heavy context. But basically, it's a method of for converting words, sentences, or documents into numerical vectors that capture meanings. So these vectors, they you can imagine them as living in a high dimensional space where similar meanings are located near each other. You can think of them as addresses in a semantical landscape. So what does it mean? I kind of plan to show a clip, but I don't want to take too much time. But basically, if you have seen this Despicable Me, the villain here, it's called Vector, if you remember, and then he's trying to introduce the uh, meaning of his name, right? You can hear the audio, right? Or no?
It's a mathematical tool.
Yes.
Represented by an arrow with both direction and magnitude.
So that's basically what I want to show you. So what does it mean, direction and magnitude? Well, imagine this is kind of middle school, high school level math, but imagine like a one-dimensional space. If you want to represent a point, you just give you one number, which is x, and then in a two-dimensional space, if you want to represent a point, then you give you two numbers. But if you want to represent like this arrow here, you kind of give out it's starting from, for example, here it's 1, 1 to 3, 3, if you will. And then the length also you can kind of represent it too. And you can do it in three-dimensional space, of course. What about four or more? If for us humans, it's kind of hard to imagine beyond the three-dimensional space. But you can see by the notation here, basically, you can do it with these notations mathematically. And it doesn't matter how much dimensions you have, you can just keep giving them numbers. It's like an address in this higher dimensional space that we are hard to imagine, but it can be represented. So if we take single words as examples here to illustrate how the AIs understand meanings with vectors, it boils down to the rough idea that the words that appear in similar surroundings tend to have related meanings. The tenet so-called that the word is known by the company it keeps. So during training, the model assigns each word a vector, which is a set of coordinates in a semantical space that represent their relationship with each other in terms of meanings. These vectors, so for example, here, imagine in a space that things like king and queen may end up with a vector that are near each other because they are both living things, they are both human, so on and so forth. So they have a lot of dimensions that are that you can assign a similar number to them. And in terms of vectors too, what's cool is that like an example that are usually used is that if we subtract the vector of man from the vector of king, it may give us something that's close to the vector of the word queen in that space. Because you're basically doing a math, you're kind of, you're doing you're kind of finding a path you're kind of finding a shape in this higher dimensional space, if you will. So this is how AI so-called understand and manipulate language meaningfully. Um, so transformer-based models like ChatGPT or Gemini, they don't just look at words, of course, individually. They analyze the full sequence, including context and word relationships. With embedding, they capture semantic relationships in a high-dimensional space and become part of the model's internal knowledge for generating or understanding text. You can think of it as a shape in a high-dimensional space in relation to other shapes in that space. A use case of this technique, if you will, is what Amber kind of referred to as the RAG, retrieval augmented generation, or like the knowledge base, if you will. So in these contexts, the text queries or the documents are converted into these kind of embeddings. And they sometimes, in the old ways, they are stored in a vector database. It is like how the model, they ingest some information like text or images in some context, and then affix them into a high dimensional space, a bit similar to if you are kind of throwing a bunch of stuffs in those like creation myth, like the gods throw things at the sky and then they become stars and constellations in the sky. And when they're needed, they go into these constellations to fetch relevant shapes and meanings in that way. This is what happens basically. When you upload a PDF to a ChatGPT and ask about what the PDF says. Although, as Ambo mentioned, many models, they have very large context. They're not doing exactly this kind of stuff. So in this way, understanding embeddings help us see how AI connects meaning across text, not just how it generates language like a chatbot, but also how it finds and uses information and so-called understands meanings, right? So already, in some ways, we can have some intuitive understanding of what the AIs are good for and what they might not be good for, right? They are usually good for finding the tasks like finding synonyms or rephrasing because they are basically similar to, if you will, if you understand it in a approximate way, they're kind of finding adjacent points or shapes in that higher dimensional space. They are usually good with simple revisions or translations because they're basically fetching the so-called constellations in the night sky in some directions. They're stretching that in the ways that you want them to do it. They are also relatively good at probable text completions or sortings because they are finding the points or shapes that fit better together or are adjacent in that space or cluster more together in a certain direction in that space, right? And usually they are not, but by contrast, they're usually not good for the so-called real world questions, like because the large language models, they only most directly, they only have access to words and the words represented in this computational way. You can kind of understand it as using kind of post-structuralism because like we humans too, we don't have real kind of direct relationship with the world. We can only kind of we are in this prison of language, right? And we are destined to understand the world using discourse and science and so on and so forth. They are getting better and better with this, but with this understanding, what I just talked about, you should know that the only thing, like us humans, the only thing, in some ways, the only access they have is words and significations, if you will. They're also relatively not so good at mathematical or rigorous logical reasoning, but they're getting better and better at that too. So I also want to show you some examples of what we can do with this understanding, which allows us to use them not just chatbots. For example, there's a tool called Nome Atlas. which is a platform designed to facilitate the visualization of unstructured text data through interactive maps. The users, us, we can upload a bunch of text or even images into it, and then this tool will generate the embeddings. And then remember that this is still in a high dimensional space, but then it uses an algorithm to project this high dimensional space into a two-dimensional space. It's kind of like how we project the Earth, if you will, into a two-dimensional map that we're using today in Google Map or whatnot. And in this interface, that the user can explore these documents in which supposedly the distance between each document, like the points, as I'll show you, they represent how far away in terms of meanings. So the documents that are similar in signification and in meanings, they are clustered more together. It's similar to a fancier topic modeling, if you will, but it kind of aids you understand how these machines, how these so-called large language models see the text that you give them. So I will basically just show you kind of very briefly what it likes. What's like. So this is, I think this one might be better. So using a Python script, I downloaded all the speech made by the late Japanese Prime Minister Abe Shinzo in the Japanese parliament. And then the raw data in the, looks like this in the lower side of the screen. But it kind of basically shows you how it kind of projects these. So each point represents one speech. If you click on that, it shows you the content of the speech. And then on the left, it shows you other attributes like in what committee it was spoken, in what number of the parliament record it was located, and the date, so on and so forth, and the party of the speaker, which is mostly Liberal Democratic Party. But this tool kind of allows you to, it kind of assigns you using the AI reasoning that it has by itself. They assign some larger topic of it, and you zoom more into it, kind of some lower level topics appear. But you can also adjust other attributes in terms of coloring. For example, if I do the dates, so the deeper the color means the later the topics that are talked about. So we can already see that in the earlier days, Abe Shinzo talked more about international relations. But what is it? If you zoom into it, it's mostly about the so-called abduction problems of the by the North Korean agents of Japanese citizens. So this was often a topic used by conservative or right-leaning politicians to urge the government or to do something about North Korea and so on. So and you can see that before he became the prime minister, he talked about these issues much more than when he after he became the prime minister. You can kind of find other things like the childcare educational issues. He talked more about it in the earlier days too. And there are other things that cluster together. So for example, here, where's the all the speech talked about agriculture and food exports that cluster together, and so on and so forth. So this is basically what I want to show you. Like this is by itself, it's not very useful or impressive in a way, but I just want to show that there are some tools that are not chatbots, but that allow you to practice or demonstrate how processes like embedding that I just talked about work, so that students or yourself may get a more intuitive and approximate understanding of the tool that you were just using, because in a fundamental way, they may just be representing the meanings in a spatial way, like the one that I just demonstrated, and that knowledge in some way give you a more informed channels of interacting with these tools that are so prevalent today. Just a second. I kind of lost my screen here. Yeah. So to wrap up, I want to highlight the utility of understanding key processes like embedding, which enables humanities scholars to use AI in a more informed way and not just as chatbots. For example, as the visualization tools that I just talked about, for a more critical and informed textual engagement. By demystifying AI processes and fostering visual and spatial thinking and recognizing biases, researchers, students, and educators can enhance their analytical capabilities in the humanities research and beyond. So that's all from me. Thank you so much.
Thank you. Thank you so much, Kuya, for this very inspiring talk. I would definitely try the visual tour. I'm thinking it's, as you said, it must be very good for the teaching, right? In the university level teaching. Anyway, I will not waste our time. Our third speaker today is Wei Hanying. So Hanying is a PhD candidate in the Department of Political Science at Columbia University. Her research interests lie at the intersection of computational social science, political imagery, and public opinion. She is currently working on projects that explore the applications and extensions of large language models in social science research. Okay, over to you, Hanying.
Okay, thank you, Professor Ren. So let me share my screen. Oh, sorry. Seems my system need to give additional permission. Please wait me for a minute. Sorry for this. I'll drop for 1 minute and then re-enter Zoom. Sorry for this. Yeah. Otherwise, I cannot share the screen.
As we have 1 minute, while we are waiting for Hanying, is there any question here about Ambo and Keyao's talk? As I said, I'm not sure about our audience, but I'm sure you must grasp, better digital literacy than I do. When Keyao just talk about the close reading, I thought, oh, I know close reading. I always do that. But then, oh, Haiying is here. And then we have the distant reading. Hi, Haiying.
Okay,
Works now?
Professor, yeah, Ren, can you?
Okay.
Yeah.
Yeah, it works. Okay.
Can you share? Can you see my screen?
Yes, I can see your screen.
Okay.
Mhm.
Okay, and hello everyone. So thank you for having me here. And this is Hanyin. So today I will introduce an AI system that help researchers to conduct academic study. And I first talk about the general in AI, like how our as social scientists and or major in humanities, how we faced AI, and then I will show you an application about the AI tools. So first, actually, in recent years, the AI have a lot of challenges to our social science. First is it have a lot of highly fast probability and also large volume data, and it can processing the data in a very short time other than our humanities. And also more and more like the things repetitive or need more experienced areas such as like coding or like driving design. There are more and more AI tools can replace many like general works. For example, like in tech company, actually they in recent days they are like tend to hire more experienced coder other than the entry level. So the undergrads or the like graduate students, they are facing challenges to like apply a new job than previous days actually. Um, and also there are other stuff like our scholars or intellectuals or main like working stuff is like recording, writing, or like judging. But nowadays, as AI and we saw they have a lot of like seems abilities that can straighten our current what we are doing for now. Uh, on the other hand, AI also bring many opportunities to us. For example, like nowadays, in previous days when we want to collect the data, it actually we need a lot of effort. But for nowadays, AI can help us like collect data and in a very like a short time, and also like the language translation, and it actually break the barriers for this. And also, for example, when in the previous days when we want to even use the NLP tools such as like this sentiment analysis, and if there are like a saturated sentiment, actually the previous like sentiment tools is not that much good, but nowadays the large language model can give us better evaluation, and also such as the event extraction. When you want to put one paragraph and to extract information, the previous when you use machine learning tools, it actually not that much good. But nowadays AI give us a more surprised like effect for these different tasks. And so in our social science, we mainly work with those different like literatures. There are a lot of like written materials. So how we deal with this? Um, so while we see that there are a lot of opportunities, actually, people may concern that AI is not that much reliable. For example, people may think that okay, the AI can actually distort the data, and there do have some like literature talking about the model also have some like illusion actually. Although you give some like maybe choose information, sometimes the AI can generate some unexisted information. And also especially for scholars, they usually like doubt that okay whether the AI is professional enough for me to use, and especially I'm doing the academic research, um it's it's not that seems not that like much like a reliable then that can help me to conduct my research. um so people are usually can worry about this, and it makes sense because it can happen, especially in the large language model. In the currently, it can have some model illusion. And so what we do is that we tried one application and doing multiple effort that trying to reduce those shortages and try to provide the researchers real application that help people conduct research. So this is called this is currently we are mainly for Chinese domestic users. So this is actually a website in Chinese. So especially for the that people who have WeChat, you can scan this account, and we have a lot of information and introduction in this WeChat account. And also for people who have like a laptop on your side, you can log in this website and can directly try, and it's currently online. So the name currently called public administration 公共管理百小生. So we originally we're beginning with public administration, but for now we already include many different disciplines in literature, including social science and humanities, such as history, philosophy, sociology, political science. So we welcome everyone and to try different questions in your own field. And I'll introduce about the system features, and then I will show you some like the online the real like real time and like answer and to see to show you the functions. So for the system design, this is basically on a retrieval augmentation generation. So we call RAG system based on large language model. So the reason why we use this is that because the general large language models, they often cannot like provide more very in-depth answers in social science or humanities, and also have some model illusions. So we basically build an external knowledge repository, and we use the RAG system. So we ingest with a lot of literature that we have validated and a reliable source, so that we also force the large language model to answer the user's question based on the literature that from the repository we built, and also give the user the exact reference list in the end. Each time when the user asks question, we give you the reference list in the end of the answer. So we want to try to reduce the model's illusion and try to provide a more precise answer towards users' questions. And so regarding the knowledge repository, we include both the literature like different academic papers, and also we include some like policy policy different documents. And so we have the important like institutional policies include the CPC Central Committee, the State Council, and various provinces. And also we have the reliable materials, the academic papers from many peer review and professional screen. So the most like all the well-known the literature journals, and so include many different disciplines. And currently we are develop about the private knowledge repository, which is we will support different users to have your own knowledge repository, because currently we are like provided the like the paper sources, and if you have your own papers, and you can upload your own private repository, and then you can ask any questions based on your own repository. So and we will also develop the knowledge repository for different teams. So it's very suitable, I think, for example, you have a lab team and you are developing one like a paper project. So it will be very convenient for you to develop your own team's repository. So here is the structure of our system. So from the beginning first, we have the historical documents, for example, like papers from journals. We first will we process with the OCR pipeline. We know that it will like translate the, for example, the PDF format into the like the Markdown or JSON format. It will be the text format, and then we will do trunking, because like in our repository, we will split the our all documents into different trunks. And so later when we system want to retrieve the knowledge, and it is actually retrieving different data trunks from the main repository, and then it is our embedding model. So the text as like others already talk about the embedding. So the text will then translate into use the embedding model, translate into the vector database. So here we can see the bottom, the user. When the user want to ask one question, the query will also like you through the embedding model and translate into vector database. So now we have the question database and also our knowledge like different data in vector database. We will calculate about the dot similarity to calculate their distance, and then we will retrieve the most like closest trunks into the large language model. For example, we will retrieve the top K and then do the re-ranking, and after we try to refine and give back refine the list of the trunks to the large language model, and let the large language model to summarize about the all related trunks and answer the question to the user. So the user will send out the query and the system do the embedding calculation distance and return the trunks, and the large language model will summarize about the trunks and then answer the question. So this is our pipeline. And so what functions in our current system? So we mainly provide three main different patterns. So the first section is about the standard question and answer. So for the first part, we mainly have two modes. One is called standard and one is called agent. I will show you very soon from the system. So it is mainly can answer your question very relatively fast and in a brief way, and it will return around about like 30 reference trunks and also still give you reference list in the end. So and also the agent is that we recently just upgrade our system and to put like develop about 6 agents in total, and those different agents have different functions for you. For example, if you want to think about try to develop one argument, and you can use our argument agent to help you develop that argument. And also we have other agents, and I will show you one by one. For example, we can take a look for now. I think you can see my screen, right? So here, this is our agent mode. Agent mode have 6 agents in total. So we have the general agent, which is it will automatically summarize different tools and to fulfill your like requirement. So generally if you don't have a specific idea to use which agent, you can usually use the general agent. And also we have this literary retrieval. And then also this is for argument agent. And the fourth one is research design agent. And this one is like to summarize about one field, like the contribution for the core literature. This one is like, for example, if you want to think about a good title for your research, and it will give you multiple research for the titles. I'll quickly show you one mode, and then I'll continue and later show you one by one. So for example, we ask about what is like the public pool resource theory, and the standardized mode will like relatively quick to give you the answer. And you can see that there are like a reference in the inner context. And also if you like hone over the reference, it will give you like the relatively trunk, like which trunk it is like referred to. And in the bottom, there are like a text format, PDF or Word format, and you can directly download. And after it finish the answer, and you can like download in different formats. And also the reference which trunk, like all the resources are way like built. So it is like we already validated the resource and the data's quality. So it is not like refer from any other unreliable sources. It's mainly come from our built knowledge repository. So you can see that in the bottom there are like a reference. So you can see that which trunk is like refer to which literature. It will give you the original source. So you can double check that whether it is like align with what you expected or not. So like in context reference have the sources in the bottom, so you can see that. And also here are some like questions I asked before. So for example, here I use general mode to ask one question in English, and then it can also answer your question in English. You can see that because we also currently have some like English literature also on the in our repository. So you can see that it will also answer in English, and you can ask follow-up question because our website also have the in session memory, and you can also ask follow-up question. For example, the translation, if you want to ask those question, and then they will confirm about this. If this question, after you confirm, it will also answer the question in Chinese. So I'll continue to talk about the slides and show you other mode. So another mode we have is called one-juan mode, and this is can answer you relatively longer. For example, it can have it like 10,000 words, and it's actually one self-developed intelligent agent, and the workflow is relatively complicated than the standard or the agent mode. And so during the process, it have like a multiple like steps, and then it will take around 2 or 3 minutes. So but after this, like waiting for a relatively longer time, and it actually can generate a relatively long answer and can combine much more like literature than the standard question mode. And so you can use this actually suitable for you want to study in depth one question or something you really want to have an in-depth argument or something. You can use the one-juan mode to try to help you answer this question, or even write a short a shorter essay or something like that. And the third part is for the team knowledge repository. This one, we are currently in progress and will online for soon. So this one we will mainly integrate about your own team's knowledge repository. So we will let you to upload your own like papers or working stuff, and all these text, for example, in your paper are in like a PDF format or like in Word format, you can all upload in this private knowledge repo, and then the system will automatically OCR for you and translate it into text format, and then you can ask questions as I showed just, but like only you and the people you are invited in your team can see your own private repository can answer the question. So this will come soon. So you can stay tuned to keep an eye on our system. So I talk about generally about what's the application scenario for this website, this system. So first is mainly we want to assist the people for the academic research. So there are many different ways to use to help you for the academic research. For example, you want to like help to understand some concept identification in class. So you can have a ask about question what is offensive realism, and if we ask this, for example, those definition question, you can directly use the a standard mode, and it can answer your question in a relatively quick way. And also, you can use this system for you to do some knowledge retrieval and contribution extraction. So for now, if you want to do this contribution extraction, for example, if you have some point of view, or you have one essay and you want to summarize about their co-contribution, in this case, you can actually use, you can see that there are also the relatively chunks they have used. So you can double check what's resources the large language model can use. So for the contribution, and you can see actually there is one agent called the contribution summary. So if you have the same purpose, and as we already have this agent, and you can directly use the agent to help you do this task. And so you can explore about those 6 agents in different purpose. So this is the first application. Mainly can help you conduct academic research and in a really quick way. And also the second scenario we can help is actually can help you, especially for our faculty here, can help you teaching and also help you writing. Because for example, if you have the lesson preparation, like the teaching materials, and you want to develop some syllabus, and actually the kind of 白小生 is really a good tool for you to help you prepare about the teaching materials. And here are also some prompt you can use when you are using the 白小生 system. And for example, to say that you are a senior international relations scholar and you want to write some textbook about IR, and you can say more details about what you want, and then you can use the 白小生 to, you will see that it can actually help you to provide many different ideas to develop your course. And also it can have the brainstorming for papers, project topics. As we just saw those brainstorming, actually our agents have this. You can see that actually the research design and those or the theory argument, those can actually to help you brainstorm about the different research design. So the third scenario is about for the policy making related. Because currently our repository also include many different policy literature. So when you want to search for about authoritative statements, for example, if you want to search what's important statements Professor she already General Secretary already she make for the China's modernization. So we can search about this. So you can see that here is for you to select different mode, but here is about for you to choose about the repository like literature or policy. The third one called mix is a combine about the literature and the policy. So when you want to ask about the policies, you can actually directly ask in select the repository that is only talk about for policy. When you call agent, actually you can see the process of agent, and they are running, and there are like multiple runs for the tools to help you investigate about the agent pipeline. And usually the agent mode can cost longer than the standard mode. And if you want to use one gen mode, and it will cost longer, and also it will like return a much longer answer. And also like for like English users, and we are also like in develop the English version about the similar tools. So we will like also put online for the English system like later, so you can stay tuned and keep an eye on our like progress. Oh, yeah, this one, it's refer many like SIS policy files, and also yeah, answering in Chinese, but you can also ask like translation into English, use the agent. Then they those are like the three main like different application tools. So this is our current user for the current system. So we put this system online in around like October. So currently it's already over like 5,000 for now, I think. And also currently there are actually many daily users, because we receive the daily like active users is also kind of like 400 to 600 people, and every day there are many like questions asked in the system. So I really like encourage everyone if you're like in different discipline, you can all like try to ask like a question in your discipline to try to use the system to see whether the system can give you a relatively good and satisfied answer. And also we really welcome your feedback. You can also like submit your feedback directly in the system. And also whether the bisection system is really helpful. So actually we already conduct experiment for this, and we basically provide the free bisection accounts to the MPA students in Zhejiang University, and we recorded about their usage time and the number of questions they asked, and in the backend. And later we also match the results about those students' CSAT proposal score, like whether their defense score is excellent, good, average, pass, or fail. And then we found that there are actually some relevant evidence in that the more frequently the student use the bisection system, and then the higher the student's chances to get a relatively better CSAT like defense result. So as we just talk about the team, like the knowledge repository will like come soon, and currently we are already develop the demo, and we will put it online soon. So it will help the team to provide the end-to-end assistance to build your like multimodal knowledge database, and so it will very convenient for like the team, or like even on your own, you are developing your like paper or projects. And we will also provide multiple functions for this. Like you can actually share share your like retrieval in your team, and also you can choose to whether you want to display to outside or not. it will come in soon, so you can keep an eye on like our WeChat account, and we will put like the upgrade or any news and on the WeChat account. And so, as this policy said, that actually also notice for the method to innovate research methods in philosophy and social science, actually, we need to like try to find some ways to like accommodate the AI era, and also actually social scientists and also humanities, this is a really good chances for us to utilize about the language model to help us like facilitate our academic research. Yeah, this is my own talk. So here is also spatial like referral code. You if you guys interested, you can use this code. So especially for our today's seminar, and if after you apply this code, and you will have some additional coins for you to use our system to ask questions. And also you can scan the QR code is for our like a public WeChat public accounts. And one last thing I may want to show you is about the one Juan mode. So, and you can also try your own, for example, like as I already show you, there are like a standard mode, agent mode, and the one Juan mode. So after you select one Juan mode, you will see that actually it will take you longer time, around 2 or 3 times. I think I will stop here, and I'll give you a screenshot after this answer is generated, maybe. So thank you.
Thank you so much, Hani. Thank you. So, there is a new guest here. We have a very stable audience today. And thank you so much, like, 3 speakers. They're intellectually rich and inspiring lectures. But that also means like we almost run out of our time. So I think as anyone has questions, we can have like, collected probably 1 or 2 questions here. And also for our audience information, Hanying and Xuanning. So Xuanning, like one of our audience here says, I'm wondering if you could recommend some DH forums or groups DH for Asia prefer that we can follow for up-to-date digital humanities news and skill.
I think the one run by Anbo that Renyi
Yeah.
posted in the very beginning is a very good source, because I think there's a workflow of uploading a lot of newest updates in the community too, right, Anbo?
Yeah. Anbo, yeah.
Yes, I mainly collect them manually, and I also script some of the information shared from other blogs, labs. It's this forum. I need to fix some pipeline problem for WeChat scripting recently, and another website I would recommend is dhcn.cn. DN or CN. It's perhaps this. I will check later on. This is one run by the lab team at Tsinghua University, got 数字中国 or something, and they also set up a. They have been running for 4 years already. They set up a similar scraping pipeline for news updates. They have even have a region catalogs you can pick and catch up on the latest news.
Thank you. Thank you, Amber. And there we have another question here that Mackenzie asked, like, exactly my questions. Like I come from a pure humanities background and know basically nothing about coding and data science. Same here, but I really want to learn about AI and digital humanities. Where should I start from? I feel I understand the logic behind it, but lacking detailed knowledge for practice. For example, I was looking the Markdown cheat sheet, but I was like, when should I use advanced code blog? What is a horizontal rule? Thank you so much. Yeah. Yeah, I have the same question. Where should I start?
Um, for something like Markdown, I think you should just start using it. As soon as you encounter any kind of issues, you should just ask AI. That's my honest answer.
Mm,
Um, and I think why we have to use that because Markdown is often trained in that format, often outputted in that format. And for something like similarly markup language based documents such as LaTeX, it was so hard back then, like 2 years or 3 years ago, to even just to remember all the complex setup dependencies for compiling a LaTeX document. But now with help of AI, either whether it's through chatbox or through the documentation-oriented workflow I just showed, it doesn't matter because AI can help you. It will remember
yeah.
the syntaxes, but for some caveat cases, you still kind of have to do your own research. Let's say you are trying to render Chinese characters, and you realize it's not the code you got from AI is not working, then you still have to figure it out. But sometimes you can still chat with AI in order to understand what's going on and where you might find some answers. For example, the AI might suggest that, okay, that might be the issue with compiler. You can search on Stack Overflow for some pointers about this. AI is your best buddy, you say.
Thank you. Thank you, Ambo. I think we stop here. It's 9 o'clock. Thank you so much. Thank you for our audience, spending your night with us. And I hope you have already got something inspiring like I did. I just got a lot of inspiration. I would just start my own experimentation. Okay, thank you so much, everyone. And also we have another
Thank you,
AI.
Yi.
Yeah, thank you. And we actually have another like workshop related to AI, specifically with the teaching in January. So I will keep you updated. Okay, thank you. Bye bye.